You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better, but as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day, and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientists in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below, and the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on. Watching a football game is exciting enough. However, what's more exciting is watching a match where things end up weird. During a match between Austria and Denmark, a mysterious hole popped up from nowhere and stopped the game. The players were furious, but also confused by this weird, deep hole. It was a Danish player who brought this to everyone's attention when his leg got stuck. The hole was deep enough to consume his ankle. Luckily, he found it before the game started. Such a situation led to a career-ending accident. He was just showing everyone how deep the hole was. On top of that, the match was delayed by 90 minutes due to a power outage. The fans were confused. Some were frustrated that the team they wanted to support couldn't play, while others found it amusing. During a game between Colombia and Brazil at the 2014 World Cup in Brazil, a giant green locust decided to land on James Rodriguez's arm right after he scored a penalty. The player didn't notice at first. I guess that green guy was a huge football fan, or the locust just wanted to congratulate him in its own way. It's certainly not the first animal to appear in the middle of a football game. Another Brazil-related incident happened when two local clubs were going head-to-head. While the game was in a heat, a dog decided it wanted a piece of the action. It got in the game and furiously went for the ball and turned it into its chew toy. The players were left stunned and agitated with the dog disrupting the flow of the game. Eventually, the officials intervened and spoiled all the fun for our little doggo. In 2006, during a Champions League match between Villarreal and Arsenal, a little gray squirrel zipped across the pitch near the striker. It was also probably just a huge fan. Ever heard a group of foxes invading a pitch? In Dens Park, a bunch of foxes decided to dig around the pitch, probably on the lookout for rabbits. Diego Maradona is one of the best football players in history. The Argentinian was quick, energetic, and wowed audiences all over the world with his passion. However, in a quarter-final match between Argentina and England during the 1986 World Cup, things went too far when he extended his fist in the air and punched the ball only for it to go behind the opposition's net. Much to the fans' fury, the goal stood. The refs didn't have a clear vision of the goal, even though they should have kept their eyes on the ball. The Argentinians were up 1 goal and the match eventually ended 2-1 in favor of the Argentinians. They eventually lifted the cup, which solidified Maradona's presence as the greatest of all time. One of the most unforgettable nights was Brazil versus Germany during the 2014 World Cup. Both are giants in the game, both with star-studded players ready to make their country proud. Both teams were crying out for different reasons. Brazil conceded a whopping 7 goals on their own turf. The Brazilian fans were furious during this historic moment. Germany ended up lifting the World Cup with Argentina as the runner-ups. The Champions League final in 2018 between Real Madrid and Liverpool was one of the most anticipated games of the year, where Liverpool was eyeing victory. Their goalie, Loris Karius, was in tip-top shape, but that night was not his night. The team and fans across the world were shocked when he made not 1, but 2 costly mistakes. The first one was when he accidentally passed the goal to Real Madrid striker, Karim Benzema, near the goal. Karius recovered the goal and didn't see the striker nearby. He miscalculated his pass and awarded the goal to Madrid. The second mistake was when Gareth Bale let loose a curling shot where Karius could have easily caught the ball. But instead of that, he tried to deflect it and the ball slipped past his hand and into the back of the net. Madrid ended up lifting the Champions League trophy and Karius' career was just not the same anymore. But it's cool because Liverpool ended up winning the trophy years later against Tottenham. Another strange fiasco happened during the 2014 World Cup qualifier, but not everyone saw this game. It was the United States versus Costa Rica, and they were playing under some of the worst conditions. It was snowing non-stop and the players were furious. The Costa Rican team even sent out an appeal suggesting that the game should have never been played, but was ultimately rejected. Team US ended up winning the match 1-0. Another bizarre scene occurred when a goalkeeper decided to check his phone during the game. The player played for Atlético Paranaense of the Brazilian League. No one knew what he was doing, but it was just impressive that he was wearing his goalkeeper gloves while handling his phone. There was a lot of drama in the match between France and Kuwait on June 21, 1982, as the latter were losing 3-1. And just like that, Kuwait conceded another goal. Nothing special except that Kuwait's leader at the time decided to march down the stands and confront the referee himself in the middle of the ongoing match. He just couldn't accept the goal and urged the team to leave the pitch. The ref was pressured to disallow the goal and the game continued. They still ended up conceding a goal late in the game. Arsenal has had a lot of legends in their squad over the decades, but none other than Nicklas Bendtner's 1.8-second goal can be matched. It's considered to be the fastest goal ever scored as a substitute in the Premier League. The Danish striker came in as a sub and headed a corner set up by Cesc Fabregas against their ultimate rivals, Tottenham Hotspur. Turning your head to check your phone or go to the bathroom when someone scores a goal is always frustrating. But when someone bags a hat trick in 70 seconds is just on another level frustrating. Alex Tor did that during a match between Rawson Springs and Wynn Gardens. The team won the game 7-1 with his goals coming in between the 11th and 13th minutes. The team was not ready for it. One of the weirdest incidents was when a referee awarded a player a red card while being subbed off. To put it into context, the player, Samuel Incoom, had received a yellow card during the match. The rules of football indicate that any player who takes off their jersey during the game will get a big fat yellow card, no matter what. He saw his name to be subbed off, and while walking to the dugout, he took off his jersey, even though he knew he had the yellow card. But he figured, hey, I'm leaving the pitch, what could go wrong? An embarrassing moment happened when the ref had to run up to him and show him the second yellow card, which turned into a red card, and he was sent off. The player waiting to be subbed in couldn't play, and the team had to play one man down. It's a footballer's dream as a child to play for the biggest clubs in the world. Some players decided to do that a little later. Multiple investigations were in action when they discovered that some people have been lying about their age. For example, Gorey Muki claimed to be 12 years younger than he was. He was 28 years old when he told his club he was only 16. A penalty shot is always nerve-wracking for both the goalkeeper and the one taking the shot. Lionel Messi, the Argentinian superstar, earned a penalty against Celta Vigo on February 14, 2016. While it wasn't exactly a romantic time, no one expected what he'd do next. Instead of casually taking a kick, he ran down to the spot and passed the ball to the striker, Luis Suarez, in a cheeky attempt to confuse the goalie and excite the crowd. It wasn't the flashiest of moves from Messi, who is considered to be one of the sport's best players in history, but it will go down in history as one of those penalties that will be talked about for a very long time.
Dark, ever-hungry monsters live all across the universe. They're born when massive stars blast into space. Black holes as heavy as Earth are just as large as a ping-pong ball. They don't have a surface, but their gravity is so strong even light can't escape it. Black holes don't have physical boundaries like a membrane either. The event horizon, which is closest to a typical boundary, is a threshold which, after passing, you can't get out. For a star, running into a black hole normally ends in a spectacular light show and its destruction. Just one star that astronomers know of managed to survive an encounter with a black hole as heavy as 400,000 suns. It happened in a galaxy about 250 million light-years away from Earth. Astronomers with really powerful equipment noticed bursts of X-rays that raged in space every 9 hours. They thought they must be Mayday signals from a star trapped by a cosmic abyss. The star was an average red giant when it met its new friend for the first time. When they got too close to each other, the hungry space monster couldn't resist the temptation and snacked on its guest. When it was done with the star's outer hydrogen layers, all that was left was the star's core. Eventually, the poor thing turned into a white dwarf. But for some reason, the giant space monster couldn't finish the meal and trapped it in its orbit for later instead. Ever since, the now white dwarf has been traveling in 9-hour laps. It stays far enough from the hole so it won't fall in or get swallowed. Its journey isn't going super smoothly. Because of gravity, the orbital path is constantly rotating. After 2 days, it resembles a spirograph pattern. As the black hole keeps snacking on it, the star keeps losing its mass and growing in size. Its own orbit is becoming more and more circular. Scientists believe one day it will be able to spiral away from its mean friend and turn into a planet the size of Jupiter in 1 trillion years. That's 70 times longer than the universe has existed so far, so it might not ever happen. The Milky Way alone has hundreds of millions of black holes, and there are way more beyond it. They might feed on other stars and release them in other galaxies. The telescopes that exist now might not be strong enough to spot them. Most galaxies, including our Milky Way, have supermassive black holes at the center. They can be billions of times heavier than the Sun. Others of their kind are only 3 times the mass of the Sun. The nearest black hole to the Earth was spotted 1,000 light-years away, just around the corner in galactic terms. It's in a star system you can see with an unaided eye. Scientists found it when they noticed a star behaving weirdly. It was a giant rotating like crazy. They guessed it must have a powerful gravitational companion. The hungriest black hole astronomers have spotted so far weighs as much as 34 billion suns and is about 6 times bigger than the one at the center of the Milky Way. It eats the equivalent of 1 sun every day. Sometimes black holes even devour others of their kind that happen to be too close to them. Before you get on a spaceship to escape to some safe, no black hole galaxy, here's some good news. Even though they're supermassive, they don't have a radius large enough to destroy Earth. And even the hungriest of them are safe to watch from a distance. No black hole should come closer to our planet than the Sun for as long as the universe has existed, multiplied by 10 billion times. In the unlikely case one of these scary things passes by Neptune, it could affect the Earth's orbit. That would be no good. In theory, anything can turn into a black hole. The only difference between it and the Sun is the material their centers are made of. It's incredibly dense in those huge space monsters. In reality, there's just one known way to make a black hole. It has to be the gravitational collapse of a supermassive star, 20 to 30 times the mass of the Sun. So, the Sun will never ever become a black hole. If it happened, though, and the former star retained its mass, it would still have the same gravitational power. Earth would still keep going around it and wouldn't get pulled in. Its orbit would also remain as it is. The only huge problem would be the lack of sunlight. In reality, the Sun isn't massive enough for such a transformation and will eventually become a white dwarf. A black hole won't ever eat an entire galaxy for lunch. There are about 400 billion stars inside the Milky Way. Just around 0.1% of all the stars that will ever form will end up becoming black holes. The ever-hungry supermassive monster, located right in the middle of a galaxy, has an impressive gravitational reach. But even that wouldn't be enough. It has already eaten most of the stars that were close to it. It already weighs like a few million suns, so it can't grow much larger even if it keeps snacking on sun-like stars. Galaxies will keep bumping into each other, and black holes will keep growing and merging. But because the universe is already huge and keeps expanding, these collisions and mergers won't go on forever. Black holes will travel this huge space like rogue stars. They won't even be able to eat the dark matter on the outskirts of galaxies. Eventually, all the black holes will perish, but that would be a long, long time from now. If you ever become a space explorer and travel far enough to meet a black hole and fall into one, your life won't instantly end. Instead, things will be way more complicated. The way you perceive space and time will change, and your reality will split in two. In one of them, you'd cease existing. In the other, you'd live and enter the hole unharmed. When you go deeper inside the hole, you'll notice space becoming curvier and curvier. At the center of the hole, it's infinitely curved. It's called singularity. Laws of physics based on the ideas of space and time don't have power here. In a large enough hole, millions of times more massive than the Sun, things would go perfectly smoothly for you. And you just keep free-falling, feeling no gravity. You could just keep falling and falling in total emptiness until you reach singularity. You'd have no chance to move in the opposite direction. In there, space and time switch roles. Time is constantly pulling you forward on Earth, but figuratively, and it would be doing that quite physically inside the hole. In a smaller hole, the force of gravity would be stronger at your feet than your head. That's why you would go through spaghettification. This is how scientists call the process when you compress horizontally and stretch vertically like spaghetti because of crazy gravity of the black hole. Speaking of spaghetti, how are black holes like an Italian dinner? Because once you go pasta the event horizon, you get spaghettified, and since you're all by yourself, you'd be feeling cannelloni right now. Wow, now I'm hungry. Meanwhile, if you had a fellow space traveler who, for some reason, didn't end up in the black hole, it would look all different to them. They'd see you stretch and grow, like through a huge magnifying glass. The closer you get to the edge of the hole, the more it would seem like you're moving in slow motion. Then you'd freeze and the flames would surround you. You'd be in two places at the same time, living different destinies, but there would still be just one copy of you. This is how black holes teach us nothing is real. Reality can be different to different people. Some scientists believe that we're all living inside a huge black hole. Everything in the universe started with the Big Bang. But there's a theory saying there was also something before that. It was a super dense seed that had all the mass and energy of the universe concentrated in it, about as heavy as 1 billion suns. It was 1 trillion times smaller than any particle humans can observe. This seed could be born inside a black hole. If you believe there's more than one universe, black holes could also serve as doors between those universes. It could be like a root that two trees share. You can't see a black hole directly because it doesn't give off any light. Scientists used to be able to only spot them by what they were doing to their surroundings. When over 200 scientists around the world worked together, they managed to take the first pictures of that space oddity. The equipment they used, added together, would be the power of a telescope the size of Earth.
There's not much to do in Antarctica except scientific work. You could check out the wildlife, like some cute penguins and seals, and you'd get to see the occasional whale swimming around. Antarctica is one of the biggest lands out there that's only inhabited by scientists and researchers from all over the world. These scientists dug a hole through some pretty thick ice to study the ancient air and how the atmosphere cleans itself. They used a special drill and dug a clean cylindrical hole 450 feet below the surface. Some of this ice can be up to 800,000 years old and is a good indicator of what the climate was like in the past. It's like checking out tree rings to determine how old a certain tree is, except it's more complicated than that. After the effortless digging, they decided to drop some ice to the bottom of the hole to see what would happen next. They heard some really unusual sounds. It felt like being on a spaceship traveling through a bunch of obstacles with many rocks smashing into each other. The pitches changed over the quick descent of the block of ice, ranging from high pitch and ending with a low heartbeat-like sound. The scientists were puzzled when they first heard this and dropped some more ice, only to find out that the same type of sounds were being produced, just in different variations. They couldn't tell what was down there and, more importantly, why these kinds of sounds were produced. Antarctica boasts quite a few volcanoes, many of which are under super thick sheets of ice. Scientists discovered 91 volcanoes and claimed there could be more, potentially making it the most extensive volcanic region in the world. While they were doing regular scientific research, they came across many unmistakable large cone-shaped figures underground. Some were as deep as 2 miles in the ice. Some of the peaks were over 3,000 feet tall and dozens of miles across. But on the surface, it's as plain as a sheet of paper. They may have dropped that block of ice inside an actual volcano that they were standing on, but it's unlikely. Even though the underground volcano presence was discovered by accident, there's a small chance they were actually standing on one where they had their workstation set up. It's more likely that they worked in an area where studying ancient climates is easier and less dangerous than other places. They collect ice samples and study them in a lab. It's like discovering a prehistoric insect embedded in amber millions of years ago when dinosaurs used to roam the land. But instead of little bugs, scientists study ancient dust, air bubbles, sea salts, volcanic ash, and anything else that may have come from the environment. They can practically tell how the climate was during that time. These ice samples might show that Antarctica's western ice sheet melted when the Earth's climate warmed up. If it did, then it's likely to happen again. That would mean sea levels rising, affecting coastal cities and small remote islands. But scientists aren't sure it's true, despite some evidence to back it up. The process of studying ice samples can take a week or even a year, depending on what they find. They crush or melt the sample bit by bit. And like those tree rings, the deeper the layer, the further we go back in time. In order to study ancient bubbles trapped in ice, researchers have to crush the samples under a vacuum hood to keep the air out while extracting the air and putting it in vials. There are various instruments and devices to study the ice samples, but because it's so sensitive to damage, each measurement must be in a clean room setting so that nothing gets compromised. The scientists have to wear proper bodysuits and many layers of gloves and constantly get ventilated. Even something as tiny and insignificant as a fingerprint can ruin a sample. They look for certain patterns to see changes in the atmosphere's composition and temperature. But dropping a few blocks of ice down a hole wouldn't be so bad. The reason why it made such a peculiar sound is the same reason why a moving car sounds different when it's honking than when it's stationary. The scientific word for it is the Doppler effect. It's an obvious change in the frequency of a wave with respect to an observer who is moving relative to the wave source. The effect doesn't mean the frequency of the sound changes, it just shifts. And this can be said about other types of waves, like water and light. But sound waves are the most popular ones when it comes to the Doppler effect. So, when the scientists dropped the ice block down the bottom of the hole, the sound waves traveled back up and bounced around the narrow tube where they drilled. That's why they got the pew pew sound. Let's not forget that this ice block traveled 450 feet beneath us. Oil ships dig holes in the oceanic crust that go thousands of feet beneath the Earth. The Kola Super Deep Borehole in Russia is the deepest hole ever made by humans. It goes more than 40,000 feet below the surface and took almost 20 years to reach 7.5 miles. Below it is only half the distance to the mantle. In terms of the whole Earth, this very deep hole is literally scratching the surface. This wasn't a hole to dig for oil, and wasn't in the ocean either. The drilling was stopped in 1992 when the engineers found out that the temperatures were 100 degrees Fahrenheit higher than they predicted. And then it was abandoned, and it's just been a barren hole now. But that's the closest we've dug to the center of the planet. The scary thing is that some of the workers on the site could hear voices coming from within. All the way in Yemen, an ancient hole exists in Barhout, in the east of the country in the middle of the desert. It's actually closer to Oman than to the capital Sana'a. This hole has puzzled experts and locals. Unlike the holes in Russia and Antarctica, this wasn't man-made. Or was it? It's been around for many years, and the locals try to steer away from it. They don't even like talking about it, since they claim it brings bad luck to those around it, or to whoever utters its name. They claim it was created as a prison for spirits, but many rule that out. The hole is 98 feet wide and somewhere between 330 to 650 feet deep. You can also hear strange sounds coming from the inside. But according to some scientists, the well has little to no ventilation and barely has any oxygen down there. So it's unlikely that anyone, or anything, lives down there. The Challenger Deep in the Mariana Trench caught some low-pitched grumble sounds in March of 2016. Some of these grumbles were followed by screeches. They caught these sounds in a span of weeks, using a titanium-encased microphone so that the immense pressure of the lowest point on Earth wouldn't crush it. They had to lower it slowly as well, since it's 1,000 times the atmospheric pressure at sea level. For 23 whole days, the microphone recorded typical sounds of whales passing by and boats sailing across from above, and even rumbles of nearby earthquakes, but they still couldn't determine what caused those initial sounds. The researchers couldn't understand if the noise from the bottom of the Mariana Trench was caused by humans or was natural. They also wanted to know if these sounds affected marine life, like dolphins and whales that rely on echolocation. They still can't figure it out, but scientists estimate that the ocean is about 10 times noisier than it was 50 years ago. With technological developments in shipping, submarines, and underwater construction, the ocean will only get louder with time. Northern lights come with sounds, which nobody talks about. They're usually audible when the auroras are at their most powerful presence. Scientists were always puzzled as to what caused the faint popping and crackling, even though they were very far above us. They used some special microphones and found out that the sounds came just 230 feet above us, which is pretty low. They're caused by electrical charges gaining power in a specific region of the auroras. The electrical charges are disturbed by magnetic storms that fire up the northern lights. As a result, some tiny sparks are released into the atmosphere, causing the faint crackling and popping noise.
Meteorites rain down on Earth every single year. Almost 63% of the 69,268 meteorites scientists have officially recorded in the Meteoritical Bulletin database have been picked up from a polar desert. From where? Antarctica. It's technically a desert because it gets little precipitation. The continent receives an average equivalent of about 6 inches of water annually, mostly from snow. The interior parts are even drier. Not much action happens to meteorites there. Deserts are like safe storage closets for them, and it's easier to spot meteorites there. In total, there are around 42,000 meteorites in Antarctica. Most of them have been spotted since 1976. The Sahara Desert in Africa isn't far behind. Nomads and treasure hunters have discovered over 14,000 meteorites there, especially since 1995. Then there's the Arabian Peninsula, mainly Oman, where they've unearthed about 4,200 meteorites. So why does Antarctica take the crown for its meteorite collection compared to other areas? It's not because more meteorites land there. Statistically, they can land anywhere. Antarctica wins because it's great at showing off these space rocks. The icy environment keeps them in mint condition. The contrast between the ice and space rocks makes spotting meteorites easy. Plus, there are spots called meteorite stranding zones, where the geology, ice flow, and climate team up to gather meteorites. Here's the sci-fi part. Satellites help researchers find meteorites. They use these space gadgets to spot the best places to search. Some of these meteorites are ancient, like 1 million years old. Now, when you think about how many meteorites there are, it's a bit like a pie chart. If you measure their weight instead of just counting them, things get interesting. Antarctica's slice of the pie gets smaller. On average, an Antarctic meteorite weighs about 2 ounces, like a small bar of chocolate. Ooh, chocolate. But in the Sahara, they've got all sizes, so the average is about a pound. Now, let's talk about meteorites in action. Only a tiny bit, maybe just 1.8% of all meteorites found have been seen falling. These are called falls. Clever name. Meteorite detectives, or meteoriticists, get all excited when they see that. The other 98% are finds. Someone stumbled upon them without seeing the meteorite take its cosmic leap. So when we only look at the ones that fell from the sky, most are called stony meteorites. These are like regular fellas of the meteorite world, but there's also a special kind called iron meteorites, or just irons. There are also super rare meteorites, called mesositerites, and pelocities, that are like a mix of metal and regular rock stuff. In places where humans live, like North America, people tend to find more iron meteorites than those that fell. That's because iron ones are usually bigger and more eye-catching. Farmers found some of these while they were working in their fields. Oh, surprise! A bunch of gigantic iron meteorites from places like China, Namibia, and the US make the chart slices huge. Now, check out this adventure. A group of scientists braving the crazy cold of Antarctica's icy desert to uncover some fresh meteorites found what they had been looking for. In fact, one of the meteorites weighed almost 17 pounds. The ones like that are pretty huge. Do they have an impact on Earth? Science says yes, they do. Meteorite impacts are more common than you think. About 17 meteorites smack Earth's surface every single day. Since most of the planet is covered with water, there are loads of places without people around. That's why these hits often go unnoticed. Most meteorites are just small bits zipping through our atmosphere anyway. By the time they touch down, they get tiny thanks to all the friction against the air. Not all meteorite impacts are wimpy. Some supersized ones have rocked our world. Remember when dinosaurs said bye-bye? Yeah, that might have been the fault of a huge asteroid. These meteorite hits are random, and they happen all the time. Scientists have uncovered evidence of a massive meteor impact even before the famous dinosaur wipeout. This impact is thought to have triggered the biggest extinction event in Earth's history. The 300-mile-wide impact crater is chilling over a mile beneath the East Antarctic ice sheet. This mega event occurred about 250 million years ago. The epicenter of the crater is in the Wilkes-Land area of East Antarctica. It might have started the breakup of the Gondwana supercontinent. It was a big landmass that included parts of what are now South America, Africa, Antarctica, Australia, and more. So, the Gondwana supercontinent started to chip off by creating a tectonic rift that pushed Australia northward. This Wilkes-Land impact surpasses the one that led to the dinosaurs' extinction in terms of scale and could have caused catastrophic consequences at the time. The Hoba meteorite is a huge chunk of space stuff chilling on Earth. It crash-landed about 80,000 years ago in Namibia. The thing is a heavyweight, like twice the size of the next biggest meteorite ever found. Interestingly, it also has a weird flat shape. Nobody's moved it since it fell, so we really don't know how deep it's hidden. But experts think it skidded along the ground like a stone skipping on a lake because it landed at an angle. That's why it didn't leave a big crater when it hit the ground. And it was discovered by chance. A farmer found the world's biggest single meteorite. He was plowing his field with an ox and a regular plow. Suddenly, he heard a scraping noise. It was the metal plow meeting the iron meteorite. The Mosi meteorite from Tanzania has been staying underground for centuries before scientists gave it a proper look. The locals loved this space gem, calling it Commando. It was known in town for generations. Mosi is made of the same stuff as its other meteorite friends on Earth, about 90% iron and 8% nickel. It weighs 25 tons. Let's talk about the El Chaco meteorite, part of the Campo del Cielo meteorite crew in Argentina. Imagine an almost 24-square-mile playground for space rocks. El Chaco, weighing 37 tons, decided to show up fashionably late in 1969. So, what if you found a meteorite? How can you tell for sure that it's not just some random rock? These space visitors have a few features that make them stand out from regular rocks. Firstly, meteorites are often heavier than they look because they're packed with heavy metals and dense materials. Secondly, most meteorites have some metallic iron, so magnets usually stick to them. If you've got a rock that's not magnetic, try suspending the magnet from a string. The third clue lies in their unusual shapes. Iron-nickel meteorites aren't smooth and round. Stony meteorites usually have a thin, crispy crust on the outside. It looks as if their surface melted a bit while moving through the atmosphere. Sounds like pizza to me. Suppose these tips won't help on your quest. Then consider this. Light-colored crystals are not meteorites. Those pretty things, like quartz, are common on Earth, but they don't hang out on other planets or moons in our solar system. Do you know those bubbly holes in volcanic rocks or melted metal slag on Earth? Meteorites don't have those either. Plus, scratching a meteorite shouldn't leave a mark. But if you scratch a dense rock and get a dark or red mark, the rock contains minerals like magnetite or hematite, which meteorites don't usually have. If you suspect finding a meteor in your backyard or something, try these tips. Just remember, to be sure, you've got to give rocks and minerals a real-life look from experts. And if you see one falling towards you, always remember to duck.
The Moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese Lunar orbiter was gathering data around the Moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the moon. The Earth has numerous satellites circling around it, but the moon is the only natural one. Our moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the moon, leaving craters as a reminder of this collision. If you're standing on the surface of the moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets, even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile-wide asteroid and its 1-mile-wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the 5th biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh. because there are no winds up there, so these tracks can stay there for millions of years. The moon has its own time zone called Lunar Standard Time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got named after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. There are possible energy sources for living beings on one of Saturn's moons. It has an ocean under the surface, and it may feature some chemical reactions similar to those that help certain forms of life on our planet survive. The moon used to have active volcanoes, probably during the time of the dinosaurs. Molten lava hardened on its surface billions of years ago, which helped create unique lunar craters, but the volcanoes have been dormant for a long time now. The moon has earthquakes, or rather, moonquakes. Just like our planet, the moon also has a crust that goes through changes and shifts. Shaking occurs when its crust warms and expands, or it can even be caused by meteorite impacts. Moonquakes are not as strong as earthquakes, but can last way longer since the moon doesn't have enough water to prevent seismic vibrations. The moon has a big range of temperatures because it doesn't have an atmosphere. During the day, it can go up to 200 degrees Fahrenheit, but at its poles, the temperature is around -400 degrees Fahrenheit. In 2019, astronauts discovered a strange space phenomenon. The moon was crossing in front of the sun, and at one moment, it seemed like it stopped and then started moving backward. It's the same optical illusion like when you're driving on the highway and pass a car that's slower than you. At one moment, as you move ahead, it may appear like it's going backward. The crust of the moon is not equally thick in all its parts. Some are up to 37 miles thick, while others are much thinner. The moon itself doesn't change colors. When sunlight goes through our atmosphere, it reflects off the moon and makes us see it as pink or red. Sometimes there are particles of dust sent into the atmosphere, and in combination with sunlight, they give the moon an orange glow. The moon doesn't have a dark side. There's only a far side that we can't see from the Earth. The moon spins on its axis once and makes a circle around the Earth, all in the same amount of time, which is why we only see its one face the entire time. All planets in our solar system have at least one moon, except for Mercury and Venus. Mercury has less mass than our planet, so its gravity is lower than ours, around 38% of the Earth's gravity. That means 100 pounds on Earth would be 38 pounds on Mercury. Because of the weaker gravity, and since it's so close to the Sun, Mercury wouldn't be able to have its own moon. It would probably crash into Mercury, or even go into orbit around the Sun, and someday even get pulled into it. Venus most likely doesn't have its moon because it's also too close to the Sun.
Do you know that these days our planet has not one, but several moons? Well, kind of. Astronomers have recently discovered another moon orbiting Earth. But it's not what you might be imagining. It's actually an asteroid trailing along beside our planet in a complex semi-orbit. The asteroid was named 2023 FW13, and instead of simply orbiting our planet like the moon does, it orbits the sun. But its orbit is so unusual that it causes the asteroid to circle Earth too, keeping it in roughly the same area as our planet, even though it doesn't orbit it directly. You've probably already realized that 2023 FW13 isn't the kind of moon where we could send a mission. It's way smaller and farther away than our natural satellite. The newly found space object is a mere 50 feet across and is floating 9 million miles away, and that's when it's the closest to Earth. This distance is around 35 times as great as that between our planet and the moon. On the other hand, cosmically speaking, it's just next door. For the first time, the Quasi Moon was spotted by astronomers at the Pan-STARRS Observatory on Haleakala in Hawaii in March 2023. Now, a quasi-moon is a space object which shares a similar orbital path with a planet, even though it doesn't orbit this planet directly. Plus, it has a steady relative position to this planet. True moons always keep a relatively consistent distance from their parent planet, but quasi-moons have more complex paths. That's because of the combined gravitational influences of the Sun and the planet itself. Quasi-moons usually have horseshoe or tadpole-like orbits. To put it simply, you can see them travel ahead or behind a planet when it orbits the Sun. Such an orbit is truly unusual, and it occurs because the gravitational pull between the Sun, the planet, and the Quasi Moon results in a complex dynamic, leading to a delicate balance in the trajectory of the Quasi Moon. When a Quasi Moon moves ahead of a planet, it tends to slow down with time, and in the end it falls behind because of the gravitational influence of the planet. Similarly, when a quasi-moon falls behind at first, it later starts speeding up and begins to move ahead of the planet. This is what creates that horseshoe shape if you look at this dance from a fixed point in space. At the same time, the orbit will look like a tadpole from the perspective of the planet. Scientists love quasi-moons because they present great research possibilities. Their interesting orbits make them perfect for studying gravitational influences and the intricacies of space mechanics. Plus, they're usually close to their parent planets, which can also offer insights into the formation and evolution of planetary systems. And who knows, maybe at one point in the future, they'll help us with space exploration. Missions to such quasi-moons could give us important information about different celestial bodies and help with the exploration of the solar system. But let's get back to our tiny moon. While it's still being studied, current data suggests that 2023 FW13 entered its current orbit at least 2,100 years ago. And according to simulations based on preliminary orbital calculations, the quasi-moon will accompany Earth for another 1,700 years or so. The good news is that the asteroid won't end up on a collision course with Earth, despite traveling relatively close to our planet. A few years ago, another asteroid was pulled into Earth's orbit and started to travel along with our planet. No larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet. Called 2020 CD3, it became our temporary mini-moon. It wasn't going to stay with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. 2020 CD3 will make another close pass to Earth in March 2044, though it will most likely not be caught by Earth again because of the greater approach distance. Temporarily captured objects, such as this one, are rare. They need to have a specific direction and speed to be captured by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. And in 2016, astronomers discovered another space rock and called it Kamo'olelewa. There was one absolutely amazing thing about this space traveler. Astronomers suspect that this celestial body could have formed after splitting off the moon during an ancient collision with an asteroid. Yes, it means it might be a piece of our moon. When specialists examined the space body and analyzed its composition, the results didn't match any of the more than 2,000 near-Earth asteroids studied before. Kamo'olelewa was too tiny and too far away for regular telescopes to study it. That's why the researchers had to find a more powerful telescope to learn more about this unusual find. After using the Large Binocular Telescope, one of the largest optical telescopes in America, and the Infrared Lowell Discovery Telescope, the scientists finally figured out what the asteroid was made of, and what they had discovered surprised them. The asteroid had light spectra similar to those of the samples of lunar material delivered to Earth by the 1960s and 1970s Apollo missions. Astronomers admit that there might be other asteroids with the same spectra, but so far they haven't found anything like that. Kamo'olelewa is another quasi-satellite of our planet. Its orbit is a bit tilted and slightly elongated, so the rock keeps leaping ahead and then falling behind Earth. In other words, it performs constant loops around us. At its closest, the 130-foot-wide asteroid gets to the distance of around 40 times that of the Moon. According to the results of orbital analysis, the rock has been following Earth for at least 100 years. We found more than 480 lunar meteorites on our planet. It may mean that pieces of our natural satellite travel through space pretty regularly. And Kamo'olelewa might as well just be the first discovered large rock split off the moon as a result of an ancient collision. Now we've already talked about quasi-moons. Let's find out more about asteroids. These space bodies are often called minor planets or planetoids. They're usually rocky leftovers from the early formation of our solar system that occurred around 4.6 billion years ago. They're mainly found in the asteroid belt between the orbits of Mars and Jupiter. Asteroids can be very different in size, from tiny dust particles and modestly sized boulders to huge bodies reaching 600 miles across. Asteroids often have irregular shapes, especially smaller ones. At the same time, large space bodies can have more of a spherical shape. Unlike planets, asteroids don't consist of layers. They're made of different kinds of metals and rocks and have no atmosphere. Funnily enough, some asteroids have moons of their own, and there are even asteroid binaries where two asteroids of similar size orbit each other. The asteroid belt located between the orbits of Mars and Jupiter has the largest number of asteroids in our solar system. There are millions of space rocks there of various shapes and sizes. But despite such a huge number of asteroids, they're widespread across the vastness of the cosmos. And if you accidentally wandered into that region, the chances of your spacecraft colliding with an asteroid would be quite low. But even though most asteroids prefer to stay in the asteroid belt, some of them make their way closer to Earth. Those are called near-Earth asteroids. Experts monitor such asteroids because of the potential risk they pose. In the past, they did affect our planet. Think of that large one that most likely wiped dinosaurs off the face of the Earth. NASA and other international space agencies have sent a few missions to research asteroids. Some of them aim to retrieve samples from asteroids and return them to Earth for study.
Imagine a giant star, a space object with ginormous mass, collapsing down into gravitational singularity. This is a region of space where the density of matter becomes infinite. In such areas, the standard concepts of space and time don't have any meaning anymore. No wonder such objects have captured our imagination. These days, we even have a few photos of black holes, or rather, the space around them. The first photo of a black hole's event horizon was taken in 2019. The event horizon is a point of no return on the outskirts of a black hole. When something, for example matter, radiation, or light, reaches this boundary, there is no way for it to escape. We can use the event horizon to estimate the size of the black hole. The larger it is, the more massive the black hole you've come across is. An international team of scientists that consisted of more than 200 astronomers had been working for years to get this result, and eventually their efforts paid off. The black hole, the region around which they managed to capture, is about 55 light-years away from Earth, at the center of the galaxy M87. People saw this amazing image thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it was tricky. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. But even though now we kind of know what a black hole looks like from the outside, we haven't figured out what might be waiting for us on the other side. Many people imagine black holes as bizarre portals to other worlds, dimensions, or parallel universes. We'll get back to these theories a bit later. So, why not jump into a black hole and go all the way to the other side? Unfortunately, such an escapade is bound to end tragically. If something gets close to a black hole, there's no escape. You might argue that you don't need to go back. After all, you want to explore what's ahead. True, but there's another problem. The force of gravity around a black hole increases dramatically the closer you come. It even creates the effect of spaghettification, when an object gets stretched into thin strands of space pasta due to the effects of gravity. When spaghettified, the matter then gets pulled into the black hole's orbit and flattened into a swirling and glowing disk of material. And eventually, this matter settles into a nice orbit around the black hole, quite far away from the point of no return. And that's not how you want your space adventure to end. Well, I don't. Getting something to cross the event horizon isn't as easy as it may seem. The material needs to be pushed out of its stable orbit around the black hole. In other words, something must make it fall in, just like it happens with the Sun and Earth. Despite the star's enormous gravity, our planet doesn't get pulled towards it, right? One of the few reasons why the material might cross the event horizon is collisions between particles. By crashing into one another, they gain some energy, and that's enough to send them spiraling into a black hole. An object entering a black hole is instantly transformed. From the outside, it would seem as if the object starts moving more slowly, because time distorts near the event horizon of a black hole. From the perspective of the object falling into the space monster, it would take an infinite amount of time for it to become a part of the black hole. When it happens, its mass will be added to that of the black hole. But even if you somehow managed to survive entering a black hole, you wouldn't be able to come out on the other side. Now, I might disappoint you right now, but black holes don't go anywhere. There aren't any holes involved. And these space phenomena aren't even black, or at least that sort of black. Black holes might seem inky because even light can't escape their clutches, but this has nothing to do with their color. Anyway, when you cross a black hole's event horizon, all paths lead to the singularity, even if we talk about a photon of light moving directly away from it. But the main problem here is that singularities are mathematically impossible. That's why some scientists suggest that when all this weird stuff happens inside the black hole, its mass gets linked to the expansion of the entire universe. And such a black hole is like a rubber band, stretching along with the universe as it expands. And as it stretches, its energy increases. And since mass and energy are proportional, the mass of the black hole increases too. But this new mass creates a pressure that makes the universe expand even more. That's the reason the universe is expanding faster and faster all the time. Wow, that sounds insane. Then, there's also a theory about parallel universes, and this multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities. According to this theory, we live in a bubble that is just one of many other bubbles. And these bubbles constantly pop up and vanish. And guess what? Right, black holes might be tunnels between these universes. Or rather, not tunnels, but wormholes. This idea that black holes could be wormholes leading to other galaxies or universes has been around for some time. It gained some fresh ground in the 1980s when a discussion started about whether an object could physically travel through such a tunnel. But since there's no firm evidence that a black hole can allow for such a passage, this remains just an idea. But if black holes lead to other galaxies or other universes, there must be something opposite to them on the other side. That's where the concept of white holes comes into play. So far, white holes are only a theory. You can imagine them as black holes in reverse, or as a ball that falls to the ground and then bounces up again. In other words, everything that falls in bounces and comes out through the white hole. But how might white holes form? One of the theories speculates that a white hole might be a black hole that has almost collapsed in on itself and then exploded outward again. What if, inside a black hole, there's a long tube that keeps getting longer and narrower until it reaches the point in which it gets so narrow that quantum effects make it bounce back? And then the super long and super narrow tube is getting thicker and wider again, and we've got a white hole on our hands. But then, what could make a black hole want to turn itself inside out? According to quantum mechanics, many things we perceive as continuous are granular. Even light is not a continuous wave, it's made up of photons. So if we apply quantum mechanics to space itself, we'll find out that the cosmos is granular too. It means a black hole can't squeeze stuff down to infinity. At some point, it will reach its minimum size. And this matter, or whatever is falling down the black hole, will have to stop and bounce back, giving birth to a white hole. What matter would such a white hole spit out? Some experts think it could be ordinary electromagnetic radiation. It would be unrecognizable from what originally fell into the black hole, since things get horrendously squashed after entering black holes. And while black holes have an event horizon, white holes would have a reversed event horizon. It would prevent anything from entering a white hole. And because of this feature of white holes, if you decided to travel to one, you wouldn't be able to even get close to it. Space. Dark, lifeless, and quiet, right? Well, apparently it's not always true. Recently, scientists have detected an eerie echo coming from the main black hole in our galaxy. It has high and low notes and sounds pretty otherworldly. What does it mean? Should we sound the alarm bell, siren, whatever? Sagittarius A star is our own supermassive black hole, sitting right in the center of the Milky Way galaxy where we live. You might know that black holes are the true monsters of our universe, gobbling up everything that is careless enough to come too close. If a massive black star runs out of its star fuel, it sometimes becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new thing becomes so strong that nothing can escape it, not even light. And so goes a black hole. We really can't see black holes since they devour everything, even light. But we can still figure out where they're located, all thanks to the existence of accretion disks. Want an explanation? Well, picture a black hole. The starving thing consumes all the matter that strays too close, squeezing it into a superheated disk of glowing gas. The black hole also bends light around it, which creates a circular shadow. That's what I mean. We can't see a black hole itself, but we can see the accretion disk surrounding it. It happens like this. First, the material gets caught in the black hole's orbit and squeezed into a razor-thin spinning band. Friction, heat, electric, and magnetic forces energize this disk, which makes the material glow intensely. The most massive black holes have such bright bands that they can outshine millions of galaxies. Inside this disk of glowing material, particles rub against one another. It slows them down and sends them straight toward the black hole's event horizon. If this friction didn't exist, the material would be orbiting the black hole for billions of years, like planets circling around their stars. Now, let's get back to Sagittarius A star. It's far less luminous than other black holes at the center of galaxies astronomers have observed. It means that, at the moment, our central black hole isn't actively munching on the matter surrounding it. What, is it catching some Z's? The answer is unclear. There's new evidence received by NASA's IXP telescope. It suggests that the seemingly sleeping giant woke up pretty recently, about 200 years ago. Ooh, that is recent. It snacked on gas and all kinds of cosmic debris within its reach. Why did it happen? And what did the black hole do after that? Sagittarius A star is the nearest to us supermassive black hole, just 25,000 light-years away from Earth. Its estimated mass is millions of times greater than that of our Sun. It sounds impressive, doesn't it? So, when scientists spotted relatively recent X-ray emissions of ginormous clouds of gas in the vicinity of the black hole, they immediately called on the IXP telescope to figure out what it may mean. What intrigued them most was how bright these clouds were. You see, most cosmic clouds, called molecular clouds, are dark and cold, with their X-ray signatures very faint. But that wasn't the case with this finding. Of course, there are a few theories concerning this phenomenon. One of the main explanations for why these giant molecular clouds are shining so bright is that they just echo a long-gone flash of X-ray light. It could mean that our supermassive black hole might not have been that dormant some centuries ago. After additional research, astronomers figured out that the X-rays coming from the giant molecular clouds were actually reflected light. And this light must have come from a short-lived and extremely intense flare that was produced either very near or right at Sagittarius A star. And the most likely cause of it is the black hole suddenly consuming a huge chunk of the material surrounding it. It happened around the start of the 19th century. It was most likely a sight to behold. Whirlpools of particles were drawn toward the black hole's event horizon, also known as the point of no return. The black hole started to ingest all this material, which resulted in brilliant bursts of X-ray light and echoes that we managed to translate into sound waves here on Earth. This discovery is crucial for understanding the processes happening to and around our supermassive black hole. We might also figure out what physical processes can potentially awake Sagittarius A star again, even if this period of activity is just temporary. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times the mass of our Sun. And 2 such giants have been recently spotted with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, mercifully also known as ALMA. 2 gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. They aren't visible directly, but are surrounded by bright clusters of warm glowing gas and stars tucked close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger, black hole. Interestingly, such immense merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe these bright and compact regions where matter swirls around black holes. Imagine how surprised they were when, instead of one black hole, they saw 2 of them, munching on the dust and gas stirred up by the massive space merger. And if before, experts thought that such galaxy mergers didn't really happen in our neighborhood, this discovery may mean that black hole binaries like this one may be much more common than we previously thought. And if pairs of black holes are so common, it can make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several hundred million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide there are in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in about 4.5 billion years. Oh, I can't wait. Now, have you heard that we might be living in a black hole? I'm not kidding. Such a scary theory does exist. See for yourself. Black holes pull inside everything they see. But what if one black hole has already engulfed us long ago? Surprisingly, some physicists deem this theory somewhat plausible. For example, Dr. Nikodem Poplovsky, a theoretical physicist from Indiana University, states that everything that a black hole swallows may turn into a new universe inside the hole or on the other side of it. Who knows? Maybe our universe used to be a quite different place until it got pulled into a black hole. The theory of white holes is closely connected with the previous idea. While black holes swallow all the matter so that not even light can escape, white holes are something quite the opposite. These formations are believed to spit out everything that black holes have pulled in. In other words, a white hole is the hypothetical area of space-time that nothing can enter from the outside, but light and matter can escape from it. As for a black hole, on the contrary, you can only enter it from the outside, but can't get free afterward.